We'll see how long I can go with my camera. It's been giving me problems lately. I got something wrong with my computer. There's something going on in the background because almost every time it tells me to close out my camera, I'm overloading the computer.
Okay. So here's the problem. I've been having trouble with these. The directions are sketch the graph of the parabola and give the vertex, focal point, and directrix.
Okay.
And I can tell you the equation. Y squared minus 6y plus 2 equals 7x.
Seven X?
Yes.
Okay. So you're into conic sections because this is not a vertical parabola. This is a horizontal parabola. What is, everybody has a different format for conic sections on the parabola. What is your standard format for the equation? Do you use 4p in the format, or?
I recall 4p. I'm not certain if I used it in this class or
Hold on, let me open my textbook here and make sure that I use the right one. It's funny how when you bounce back and forth between different formats, it's hard to remember the format. So here's the two common formats. If it's a vertical parabola, then it's x minus h squared equals 4p times y minus k. And if it's a horizontal parabola, it's y minus k squared equals 4p times x minus h.
Okay.
In other words, we need to take this formula and get it into one of these two formats. Well, we can see it's got to be this format up here. And there I go, getting the message. I got to turn my webcam off. So I'm going to answer yes. Okay. Hopefully that will stop any problems. Can you still hear me okay, Cam?
That's fine.
Okay. So how are we going to get this format into this format?
So we have to identify k and h.
Yeah, we're going to have, notice that this format over here is y minus k squared, which means we're going to have to complete the square. In other words, we want to be able to start off on the left side of this equation with a y minus k squared. And we do that by completing, that's our plan, is to complete the square. Well, let's take, for the moment, let's take this 2 and move it to the other side. So it becomes a minus 2. And now we can complete the square. Remember how to complete the square?
So that'll be y minus 3 squared. Oh.
Yeah. No, you're right. It would be. But let's not skip that intermediate step because there's something real important we have to do. So that's y minus, or y squared minus 6y plus 9. In other words, we have to add 9 to the left side of this equation in order to be able to represent it as y minus 3 squared. And when we do that, we have to add 9 to the other side of the equation. Okay?
Yeah.
So far I haven't changed anything. And now how do we rewrite the left side?
Y minus 3 squared.
And how can we make the right side look like this? We're trying to make it look like 4p times x minus h.
So would it be 4 times 7 times x plus 1?
Yeah. In other words, we're going to factor out a 7 so that we're going to have this. And now we know what k is, we know what y is, and we can figure out that 7 has to equal 4p. So therefore, p is equal to 7 divided by 4.
Oh, I see. Okay, that makes sense.
Yeah, and you want to be careful about skipping any of these steps. Just because if you went straight from here to here, you might forget to add that 9 to the right side.
Yeah.
All right. You have others like this? Or I presume you're into conic sections, so you're doing circles and ellipses and everything, or?
Yeah, so can I try graphing this one down?
Yep. What did we get? We got k was equal to 3. H was equal to minus 1. And that's our vertex. So the vertex is at 3 minus 1. We know that since the coefficient of the y squared term is positive, that this is going to open to the right. So it's going to look something like this. And the focus is equal to p, which we know is 7/4. So we're going to go 7/4 n. So there's the focus. What's the coordinates on that focus going to be?
So that would be 7/4 negative 1.
It's 7/4 distance from the vertex.
Oh, okay.
Remember, the vertex is at 3 comma negative 1.
So it would be 3 plus 7/4, whatever that would be.
3 plus 7/4 would be 4 3/4. Would be the new x coordinate. What's the y coordinate?
Negative 1.
Okay. And then do you have to find the directrix also?
Yeah.
Okay, the directrix is perpendicular to the line of symmetry of this horizontal parabola. And so it's going to be the same distance from the vertex as the focus is. So what is the equation of this line? X equals something.
X equal, so would it be minus p then this time?
Yes.
Okay, so p minus 7/4.
Which is 5/4.
Yeah.
So x equal 5/4 is the directrix.
Okay.
Okay?
Not so bad.
No, actually parabolas are probably the hardest. I think they're, well, for me they're hard because I bounce back and forth between this p, and some schools don't use p. And then yet they have you figure out the focus is that coefficient divided by 4a or something like that. I don't remember. But everybody uses the same thing for circles, ellipses, and hyperbolas. And so I actually think those are easier.
Okay. All right, I can find another problem.
Okay. If you have another parabola problem you want to go over, let me leave these equations up.
Um,
If you want to go straight to,
let's try another one, yeah. So here's the equation. 2x squared minus 12x plus 3y minus 18 equals 0.
excuse me, 2x squared minus 12x
Plus 3y minus 18.
minus 18
Uh-huh.
equals 0.
Yes.
What kind of figure is this?
That is vertical parabola.
Okay, so we want to get it into this format.
Yeah.
Okay,
So we put the 3y into 18 on the right side.
okay. Okay.
And then we can, and then for 2x squared minus 12, let's divide out 2 from that, and then we get x squared minus 6x, and then, and I guess you could get x minus 3 again, so you add 9 to one side and subtract 9 to the other.
Okay, be very careful here. I have to write in a 9 there, but what have I done to the left side?
You subtract 9.
What have I done to the left side? When I
Oh,
wrote
you
the
add,
number, I added 18 to the left side because this 9 is being multiplied by this 2.
oh,
So
yeah.
I have to add 18 to the right side.
Yeah. Or to subtract 18.
No, I got to do the same thing to the right side as I do to the left side. Now,
Okay.
occasionally when we complete the squares, there are other math problems where, well, particularly if you're trying to put a quadratic into vertex format, when you complete the square there, you leave the numbers on the same side. So then if you add 18, you got to subtract 18. It all depends on whether you're doing everything to the same side of the equation or different sides. In this case, we're doing different sides because we know we're going to end up wanting a y and a number on the right side.
Okay.
Okay? All right. So now we've got
2 times x minus 3 squared equal to negative 3 times y minus 12.
Yep. Okay, now what?
And then we need to find p, so 4p equals, well, actually, what do we do with the 2?
We gotta divide both sides by 2.
Yeah.
In other words, if we're going to use this standard format, there's no coefficient in front of this. So we've got to get it to 1. So,
Okay. 2 divided by 2. Now we can find 4p.
yeah, we can find 4p. Let's start with that. 4p equals minus 3 halves. So p equals minus 3/8. And h is equal to 3. And k is equal to 12. So now we can graph it. The vertex is 3, 12. Up or down?
Let's see, what's the, I think it goes down?
Yeah, because of the negative sign.
Yeah.
In other words, p is really without sign, but we know it goes down because the original equation is going to have a negative on the x squared part. If we were to solve this for y and put it up that would be a negative coefficient in front of the x squared. So we know it goes down for that. And it's broad. This is where I kind of get confused. Let's see. No, it looks like that. No, the focus is below that vertex by 3/8. So I suppose we could look at the negative sign on the P being the direction we're going to go. We're going to go down 3/8. So this would be 3, 11 5/8. And the directrix, what's the equation of that?
You want me to find the directrix?
Well, yeah. Isn't that part of the problem? You have to find the vertex,
yeah,
the focus, and the directrix?
Yeah. So it would be 3 minus 3/8, which would be 2 7/8.
Remember, we're looking at the y coordinate here.
Oh, whoops! It would be 11 7/8, I believe.
11
No, I'm doing
11 5/8.
11 5/8. We're doing it the other way.
Excuse me. It's 12 plus. It's 12 plus 3/8.
Yeah, so it's 12 3/8. My bad.
Yeah, so it's 12 3/8. There we go. In other words, this sign tells you whether it opens up or down, or right or left, but once you go to put the focus, you know to put the focus inside the parabola, and you know to put the directrix outside. So that's what I would go for. Don't try to figure out these coordinates by the sign on P, but look at the graph. Okay? Are we doing all parabolas today, or do we have other stuff too?
Yeah.
Or are they just giving you equations and having you graph?
We have some other stuff.
Okay. We've done one of each parabola.
I've got something. Find an equation for the given parabola, let A equal -1/2, and it's a parabola with its vertex on the at 0, 0, and it's going down.
0, 0.
And yeah, the vertex is pointing down.
We need to find an equation that does that?
Yes.
Okay. Which format are we going to use? One on the left or the one on the right? This one or this one?
We're going to be using the one on the left.
Okay. H and K are
H and K, since it's vertical.
okay.
Parabola.
So H and K are both 0. So our equation is going to be x squared equals 4p times y.
And then 4p is equal to A, am I right? No, wait.
Yeah. 4p is equal to A, which is equal to -1/2. So p is equal to -1/8. And so the equation is -1/2 for 4p.
Yeah.
In other words, if the only thing they wanted you to do was find the equation, there it is.
Yeah. Okay.
So we didn't really need to find 4p. We just knew that A was the coefficient in front of the y.
Yeah, that was good to know anyway.
Okay.
Hmm. Okay. Now let's try this one. Determine the equation of the parabola that satisfies a given condition. Focus on -4 and 4. Directrix y equals -4.
-4 and 4?
Mm-hmm. And the directrix is y equals -4. So it looks like,
Is that all we know?
yeah. It looks like the focus will be, well,
Well, let's try to draw such a thing. First of all, we'll put the directrix in with a dotted line.
uh-huh.
And then we'll put the focus in. -4 and +4. So that's the focus. So we know this opens up somewhere right there. Correct?
Yeah.
Okay. So what is that? Let's label these -4, 4. And this is at -4. So what is the y coordinate? In fact, what is the x and y coordinate of the vertex?
The x coordinate is -4, the y coordinate is 0.
Okay, so let's draw this a little bit better. What else do we need? We need the equation of it.
Yeah, the equation.
Let's start up here under the equation on the left. And we've
So,
got x minus what?
so our h is 4.
H is -4,
Yeah, -4.
which means it's going to be x plus 4
Yeah, all that
squared. And then P was 4.
Uh-huh.
So 4P is going to be 16 times y minus 4. So there's your equation. Now, I'm sure that's fine. K is +4, and that's why we write y minus 4.
I thought a vertex is based off a vertex and it's 0.
You're right. Excuse me. Excuse me. Yeah. Yeah, I was putting the focus in there. Okay. I think that if you have any problems with these problems, that you can't go wrong by starting out writing that at the top of your sheet.
Yeah.
Knowing that this is a vertical and that's a horizontal.
Yeah.
And then it's just a question of plugging into the proper equation. All of these result in that. If you can't recall it from memory, if you have it in memory, then you might not have to do that. But what I've found is if you keep doing that, if you always start off every problem writing the appropriate general equation, eventually you memorize it really well. And it definitely helps with the accuracy of doing the problem, making sure you get the signs correct on everything. And
Okay. Well, I guess we could do another one.
okay.
Let's see, this is a word question. A light has a parabolic cross-section with a depth of 3 inches and a cross-section height of 6 inches. Where should the light source be placed to produce a parallel beam of light?
So they're asking about a focus point.
Yeah.
I guess. I didn't quite understand the problem again. Can you read it again?
Yeah. A light has a parabolic, I could actually copy and paste it into the chat bar.
Okay, let's do that.
Yeah.
It'll be easier for me to read it than understand it. I'm having hard times with the audio on your end a little bit.
Yeah, it's also pretty wordy, so. There we go.
Okay, light has a parabolic cross-section. Okay, let's see if we can draw a picture. So this is 3 inches. And height of 6 inches. Do they show you a picture on this at all?
No.
Okay. I'm thinking. Oh, okay. I've oriented this wrong. Let me orient it properly. And in fact, let me put a coordinate system in this thing. Okay, so the depth is 3. So this point here is 3 comma 0. And this is got to be the height, so that's got to be 0 comma 3. And this has got to be 0 comma minus 3. And they want to know where the focus of this thing is. In other words, where should the light source be placed to produce a parallel beam of light? If we put a light source here, it's going to bounce off this focus or every edge of the light and go out parallel to the line of symmetry. In other words, a beam of light, this would bounce off this way. Okay, so that's what they're talking about. So now let's solve the problem. Let's see, what do we know about this? We know it's horizontal, so it's got to fit this format. We know the vertex is at 0, 0, so that makes it fit this. And we want to solve for P, correct?
Yes.
Okay. Well, we know some points on this thing. Let's plug them in. We know that point's on the curve, correct?
Yeah.
So if I plug in the x and y coordinate into this equation, I'll solve for P. So 3 squared is 9 equals 4P times 3, so 12P. So P is equal to 3/4. So the light bulb should be put 3/4 inches from the vertex.
All right. This is all I have for this section.
Okay. Are we on to circles now?
Yeah, we could start on the ellipses.
Or ellipses, either one. Circles are pretty easy, but circles involve completing the square in order to find where the center is and all of that good stuff, but they don't have a focus or any of the hard stuff, so if you want to do ellipses, that's fine. We can do whatever you need to do. I was just speculating and guessing as to what was next. But
Yeah, I have ellipses right now, so that's the next homework anyway.
okay.
It doesn't look like it's going over circles right now. Okay, so let's see. X squared over 49 plus y squared equals 1. That should be pretty simple. Yeah, we need to find the vertexes, the focal points.
No denominator under y?
No denominator under y. This one's
Okay, let's do the same thing we did last time. Let's write out the two equations. What are they?
It should be y minus k squared equals 4p times x minus h, and vice versa, x minus h equals x minus h squared equals 4p y minus k. Oh yeah, these are different equations.
It's either this or this. This being horizontal ellipse, excuse me, this being the horizontal, and this being the vertical. I usually write these in opposite order. I tend to think more of the horizontal ellipse as the standard, and the vertical ellipse is different. But the big thing is that A has to be greater than B. A always is greater than B. Okay? So which one is this?
So this one is our vertical.
Okay, because 7 is greater than 1. So it's horizontal, excuse me, because 7 is greater than 1. It fits this over here.
Oh, okay, I see.
In other words, the big number, the big denominator is under x, makes it horizontal. If the big denominator is under y, it's vertical.
Okay.
Okay, so they want to draw an ellipse. Let's start with H. H is 0. K is 0. A is, B is 1. And C, which is the distance to the focus, is what? So we've got one more equation up here we want, which is c squared equals a squared minus b squared. And notice that because a is always greater than b, then when you solve for c, you're not solving for the square root of a negative number. And that's one way I memorize this, and I know that there's that caveat that if you write this, or if you get the wrong a and b, you will find yourself solving a c and getting the square root of a negative number. So if you ever find that, you know you've got something backwards. Okay? So c is what here?
Root 48.
Which, let's go ahead and simplify that.
Let's see. So we have 2. So we have 4 root 3, I think?
Uh-huh.
Yeah.
All right, so now we're ready to graph it. Where should we start?
So our vertex is at 0, 0, am I right?
Yeah, so let's start there.
Mm-hmm.
And then what's the right major vertice going to be?
It's going to be 7, 7, 0.
Left
Or
one,
negative 7, 0.
-7. And the top minor vertice,
Is 1. 0, 1, sorry. And 0, negative 1.
and the foci
Does the foci go on the inside or the outside of it?
inside, always on an ellipse. In other words, our ellipse is going to look like this. And the foci are always, I use X's for my foci to kind of distinguish them. And what's the form or the coordinate of this foci?
So that would be 7 minus 4 root 3, 0.
The foci is measured from the center.
Oh, I'm sorry. So it would be 4 root 3 and 0.
And this one is -4 root 3, 0. And that's everything there is to know about that ellipse.
Okay. And now I would enter the end roller here.
Other than the reflective properties. The reflective properties of an ellipse are such that if you shoot a beam of light from one foci, it will always go to the other foci, no matter how you shoot it.
Okay.
Okay?
Let's see here. So I'll just enter it in real quick. Okay, so the next one we have is x squared over 25 plus y squared over
X squared over what? X squared over what?
25 plus y squared over 49 equal to 1. Okay. So center that's here again.
What's A?
A is 5. And B is 7.
No, remember this part? A has to be greater than B always.
So A is 7.
Okay?
And B is 5. So that means it's a vertical ellipse. E is equal to C squared is equal to 25 plus 49, minus 49 minus 25, right? And that would be 24, root 24. And that equals to 2 root 6.
Okay? So there's the center.
Mm-hmm.
What's the top major vertice?
The major vertice is 7, 0?
0, 7.
7, sorry, 0, 7.
Because this is a vertical ellipse.
Yeah. 0,
And the minor vertices?
5, 0, and negative 5, 0.
So we're looking at, I'm never very good at drawing ellipses. And the foci, top one?
That would be 0, 2, negative 2 root 6, and the other one would be 0, negative 2 root 6.
Okay.
All right.
In fact, you know, if I was taking the test, I'd be real tempted to write this stuff at the top, out at the top of the page before I started working. I don't know. It depends on how fast you could do it, if time is an issue, but I think it's really helpful having this stuff.
Yeah, time usually isn't too much of an issue during this test.
Okay.
You can usually finish during the time given.
Having these standard general equations just makes the problem flow so much easier. You don't have to constantly recall from memory and stuff. Okay, got another one?
Okay. Here's another one. 25x squared plus 9y squared equals 225.
225?
Mm-hmm.
Okay. We haven't had one yet where we've had to complete the square. Those tend to be a little harder. Hopefully we'll have time to do at least one of those. So what's the first step here?
I don't know if we can divide it by 25.
Divide everything by 225 whether we can or not.
Okay.
In other words, even if it's not divisible, we're going to end up with fractions as a and b, and there's nothing wrong with that. The key here is to make sure we get this right side to 1.
Yeah, okay, I see.
Okay, and it turns out that 25 does go into that. Well, it goes into 208 times. It must go into that 9 times.
Okay, so this does a whole bunch of...
This must be 25.
Oh, wait, it will be for the course. Huh. Yeah, that's right, because it's a smaller number.
Okay. So, you want to go through this, or shall we try to find a tougher problem?
Yeah,
I mean, once we got it to this state, I know you know what to do.
Yeah. This one looks kind of interesting. 16x squared plus y squared plus 160x plus 384. I can actually just start typing these in. It might be good.
That's okay. Go ahead and read it again. I think I got...
So the 16x squared plus y squared plus 160x plus 384 equals 0.
Now notice right off the bat that we have a y squared but no y. We have an x squared with an x, which means we're going to have to complete the square. We're going to end up with an x minus h quantity squared. K will be 0. So right off the get-go, I know we're going to have some h and a k that's 0.
Yeah.
So let's start getting it to the format that we need.
Okay, so we can divide out 16.
Okay. And this becomes that.
I guess we can divide out the x.
Let's just rewrite this for a moment like this. We know that we need that number on the right side.
Yeah.
So all I've done is combine the x squared and the x, factored out the 16, and left the y squared where it belongs. So let's complete the square inside.
So we have that plus 25.
I know you're suspicious because we got a negative number over there, but trust
Yeah.
me, it's going to disappear here in a second. So what do I have to add to the right side?
25?
Times 16.
Yeah.
So I have to add 400. Okay?
Oh.
So now everything's going to fall into place. We got
Uh-huh.
16 times x plus 5 quantity squared plus y squared equals 16.
Yeah.
Now we're going to divide what? What are we going to do next?
Divide 16.
So now we got x plus 5 quantity squared plus y squared divided by 4 squared equals 1.
Mm-hmm.
We know we have a vertical ellipse because 4 is bigger than 1. So let's go through. H is what?
H is negative 5.
K is
0. So it's simply that negative 5 and 0.
A is, you know what, before we write A, let's write vertical or horizontal, vertical. Now we know where to get A from. The Y, whatever the denominator of the Y is. So A is 4, B is 1, what is C?
C is root 15.
Which is simplified because it's the product of 2 primes.
Uh-huh.
And now we know how to do it. We've done the tough part. Once we get to here, I know you know how to do the rest.
Yeah.
In other words, we know it's vertical, its center is right here. So it's going to look something like this. Maybe we should go through this because we have to do one thing different here. Let's just make sure you remember what that is.
You have to shift it to the left 5 places.
Well, what's the coordinates on that?
That would be negative 5, 4.
Coordinates on this one.
Negative 5, negative 4.
These coordinates here are slightly different technique.
Yeah, so that would be negative 4 and 0.
Okay. And this one over here.
That would be negative 6 and 0.
And this focus here and this focus here.
So that would be negative 5 and root 15.
So it's written this way, negative 5 comma root 15. Sorry. I was thinking of something else. And this one's negative 5 negative root 15.
Yeah.
What I was thinking is that occasionally you have to express coordinates like the following. 3 minus root 3, that's the x coordinate. Maybe the y coordinate would be 4 plus root 6. And that's the correct way to write it.
Yeah.
We didn't have that in this situation. I was thinking we were going to. But yeah,
All right.
it would require a y coordinate not to be 0, or the k not to be 0 to have that in this problem. Okay, we got 10 more minutes.
Alright, so we do another one similar to it. 16x plus 32y
Hold,
plus 4x.
1 second. Let me start with that. Go ahead. 16x plus 32y.
32y, yeah, 64x. That's actually 32y squared, sorry. Minus 256y plus 64.
Okay. This is going to be one like that, where we're going to have to express the coordinates as a number plus, of course, now watch C be rational. So, but hold on. I have to go through this process because I want to always have that top available. Okay. So what's the first thing I'm going to write?
So you're gonna subtract 64 from the left and put it to the right.
Okay. And at the same time, I'm going to regroup and factor at the same time. So I'll do it all at once here. I got 16 times x squared plus 4x. I'll leave room for plus something else. Plus 32 times, again, I don't care if it divides evenly into 256. I've still got to factor out a 32. Must divide evenly, 8. So this becomes 8y. Check the sign. It's going to be negative after the parentheses. That's what we want it to be. Okay. Now let's do our next step.
So that would be 4 plus 4, and then you add 64 to the other side.
Okay.
And then for the other one, you have 16. You add 16 to the other side.
Not 16.
32 times 250. No, not larger than that. You would have 512.
512? Okay. Okay, so now let's rewrite it as 16 times x plus 2 squared plus 32 times y minus 4 squared equals 512. Okay?
And then you divide 512 for both sides.
Okay. Let's see, we know that's 32.
Yeah.
I think, right? Didn't we just determine that 16 times 32 was 512?
Yeah.
Okay, so this must be y minus 4 squared over 16 equals 1. Okay, let's rewrite that as 4 root 2 quantity squared. Let's rewrite. Don't have to do this part. I just kind of do it for clarification. Okay. H
equals -2 and k equals 4.
A vertical or horizontal?
This is horizontal.
So A equals
4 root 2 and B equals 4. And C equals 32 and 16.
C is equal to the square root of A squared, which is 32, minus B squared.
Oh, whoops. Let's go back. So the C would equal 4 then.
But that's impossible. Isn't it? No, it's not impossible. I just realized it's not impossible. I was thinking that would put the focus on the edge of the ellipse, but it's not going to. So our center is right here, and that is minus 2 comma 4, and it's horizontal, and A is 4, B is 4, so it goes on the other side. Something like that. What's the coordinates of this vertex?
So that would be 2 plus 4 root 2 and 4.
Here's the way to write it is start from the center,
Yeah.
minus 2 plus 4 root 2.
Yeah.
That's the x coordinate. Y coordinate is 4.
Okay.
This vertex over here is minus 2 minus 4 root 2 comma 4. What's this vertex up here, the minor vertex? Erase some of this stuff here.
Negative 2, 8.
No, remember this is just, oh, excuse me, my mistake. You're absolutely right. And this one down here.
Is minus 2, 0.
No, I didn't draw it right. Okay. Doesn't really matter. Yeah, if you draw it right or wrong, as long as you get the coordinates correct.
And then, so our focuses are 2 comma 4 and negative 6 comma 4.
Good to go.
Mm-hmm.
Okay. You want to look at next week's calendar for the next session?
Yeah, next Friday would be fine.
Friday at 10?
Yeah.
Okay.
So I'll be having the final, so yeah.
Let me put you in there. I will see you next Friday.
Sounds good.
All right, Cam. Talk to you next week.
Right, sounds good.